Hello. Today we will talk about the concept of limits. This is the first of the four major lessons in the crash course for calculus. So, there's a few ways to understand limits. The first one is visually, and that's what we'll do today. We can also calculate limits analytically, but that will be for the next lesson. So first of all, what is the notion of a limit? So we can start with a graph. And that's my x-axis, that's my y-axis. Let's use the function f of x equals x minus 1 over x plus 2. And graphically, we have something that looks like this. And the questions we can ask from this is, what is this notation right here? And when we write something like this, we mean, what is the limit as x approaches a of x minus 1 over x plus 2? So intuitively, you can define limit as x approaches a of f of x equals L, and we say the limit of f of x as x approaches a equals capital L. And what are we saying? We're saying as the x values gets closer and closer to this a, your y value is getting closer and closer to this L. So going back to the question here, what this is saying is as x on the x-axis, if I note down 1, if I see from both the left-hand side and the right-hand side, what value am I getting closer and closer to? And it turns out both the y values are getting closer to 0.5. And that is the visual idea of what a limit is. So let's look at a couple more examples graphically, right? Yes. How about let's do a piecewise function. And so let's do a graph. All right, let's use two functions here. Or one function with two branches, let's suppose y equals g of x. And let me do 1, 2, 3, 4, 5. On the y-axis, let's call it 1, 2, 3, 4, 5. And we will draw a function here. 2, 1 goes to 2, something like that. And at 5, it has a hole in here. And on the left-hand side, it has a hole at 2, goes through 2.5, and something like that. So that is our function. And so one definition of a limit, and how I would like you to think about it is that limit as x approaches a of f of x is equal to this capital L, if and only if the left-hand limit and the right-hand limit are the same. So limit as x approaches a from the left, that's the left-hand limit, and the limit as x approaches a from the right of f of x is also equal to a. So let me define this. Limit from as we approach from the left and limit as we approach from the right. So let's do a few examples looking at this picture. So what can we say is the limit as x approaches 2 from the left of g of x? Okay, so this is 2, this is my x. Now if I'm going from the left, I'm getting closer and closer to what value, y value? I'm getting closer and closer to 3. Alright, let's do something else. How about the other way? Limit as x approaches 2 from the right. If I go from the right, let's see what's happening. I'm getting closer and closer to 1. Now, are the right-hand limit and left-hand limit equal to each other? No. Because 3 is not equal to 1, we can say limit as x approaches 2 of g of x does not exist. Right, so DNE is our keyword. Does not exist. Alright, let's do another one. What about let's look at the x equals 5. So limit as x approaches 5 from the left. Now what's happening here? We're getting closer and closer to 2. How about the limit as x approaches 5 from the right? Well, here also we're getting closer and closer to 2. And if the left and the right hand limit are the same, then by this definition, we also have the limit as x approaches 5 of g of x is equal to 2. But here is an interesting thought here. There's a hole here. G of 5 is actually not equal to 2, it's equal to 1. Despite that fact, the limit is equal to 2 because from the left hand and the right hand, the values are getting closer and closer to 2. Well, that's the intuitive definition of a limit, and next time we'll start doing some examples.